Hi, I'm Patty Betzing from Eastmont High School, and today we are going to be looking at solving trig equations using a variety of different methods. So we'll start by talking just a little bit first about solutions. And I wrote this down because this is something that's really important. Solutions to an equation are the values that make the equation true. Now when we're working with trig functions that are periodic in nature, we should expect to see an infinite number of solutions or multiple solutions because it's repeating with each period. So it's not always just going to be one answer and you're done. A lot of times they're going to want all the solutions and we're going to have to think about all the possible values that make it true. So we're going to have to be very careful of that. So let's look at a real simple trig equation. So this one just says that cosine of x is equal to 1/2. And the instructions are asking us to first, using what we know about the cosine function, to find the solutions of the equation that are just in the interval from 0 to 2 pi. So that's just in quadrant 1, 2, 3, or 4. Then they want us to use a calculator to find the solutions that are on the interval from 0 to 2 pi, which should be the same answers we just got. And then we're going to move into finding all the real number solutions for the equation. So we'll start by just using what we know about the cosine function to try to find the solutions. So I know that the cosine is positive in quadrant 1 and quadrant 4. So I should recognize this, but if you don't, you can draw a reference triangle. I don't know if you can't see that very well. Let's see if I have a visual shot. So I draw a reference triangle in there. And if this side is 1, this is 2, and this side is radical 3. And I know that's hard to read, but we'll come over here. You should already know that anyway. So I know that the cosine of a 60-degree angle is equal to 1/2. Okay. Now it wants all the solutions between 0 and, or on the interval of 0 and 2 pi. 60 degrees is not in radian mode, so I'm really looking for the answer of pi over 3. So at pi over 3, the cosine is equal to 1/2. Now I know that that's going to happen again in quadrant 4. So if I were to draw my triangle down here, this measurement is still 1, still 2, radical 3, but I need to know what this angle is. Well, I tend to think of it as -60, or negative pi over 3, but negative pi over 3 is not in the interval I'm talking about. So I need to think of it as the coterminal angle and come around this direction and think of it as 5 pi over 3, okay, which would be 300 degrees. So those are the values of x between 0 and 2 pi that satisfy that situation. Now, using our graphing calculator, so let's see if I can turn this calculator on here. It's on. So using the graphing calculator, let's see if I can figure out how to do this here. Y equals, I need to clear that equation. And I want to look at the cosine of x. And I want to know where it equals 1/2. So for y2, I'm going to put in 1/2 or 0.5 since I'm using a calculator. And let's look at our window. I need to make sure I'm in radian mode. Actually, let's go ahead and do this in degree mode and see if we're getting 60 and 300. It'll be easier to see than working with radians. So arrow over, make sure your calculator's in degree mode. And then we'll go to our window. And they want us to look on the interval between 0 and 2 pi, but if I'm working in degrees, I want 0 to 360. There we go, that's a little better. And then for my scale, I'll just go up by increments of 30. For my y minimum, I know I'm working with the cosine function. You should know that the range goes from -1 to +1. I like to go a little above that, so I can go -1.5 to +1.5. And I'll just leave the scale at 1. And so we'll look at our graph. Okay, so there's a cosine function. Looks just like it's supposed to. We're showing one period of it. And these are my two solutions. Now I'm hoping that this is going to give me the values of 60 and 300, which would be pi over 3 in radian mode and 5 pi over 3 in radian mode. So let's double check that. So we're going to go to calculate. So I go second, trace. I want to find the intersection, so I'm going to choose number 5. It asked me for my first curve. Now remember, it'll go to the closest intersection point, so I usually get it closer to the one I'm looking for. So I'll find this one first. Do I want the cosine curve to be my first function? Yes, so I hit enter. Do I want 0.5 to be my second curve? Yes, so I hit enter. Do you want me to guess? Of course I do. And I get 60 degrees, which would be pi over 3 in radian mode. Okay. And then when I'm looking for the second intersection, I'm going to just do that process again. Second, calculate, intersection. I can also just arrow down to the number 5 and hit enter. Oops, I didn't hit that. Second, calculate, 5. Stick with what I do. On this one, I want to make sure that I'm closer to the point I'm looking for. So I need to get my cursor over closer to that second intersection point. Your calculator is easier to use than this one. You can just hold down that button and it will move. First curve, yes. Second curve, yes. Yes, yes. 300, which we know is 5 pi over 3. So we have found both of those solutions. Now the last thing it asks me to do, I'm just going to keep it on this calculator screen. The last thing it wants me to do is to find all the solutions to this equation. So I'm going to expand my window. I'm going to keep my equations the same, but I'm going to go into my window and I'm going to expand my window out. And I'm just going to leave it in degree mode, but I'm going to go from negative 360. And instead of just stopping at 360, let's expand that out to 720. So that's going to give us 3 cycles of our curve. I'll leave my scale at 30 and everything else is going to stay the same. I'm going to look at my graph. Notice it's still that characteristic cosine curve. There's the value of 1/2. Now I'm looking for all the solutions. So I want you to take a second and put in these equations on your calculator, these two. Make sure you have your window set to go from negative 360 to 720 and find all the intersection points on there. Work with somebody else, but get all of them. So you should have 1, 2, 3, 4, 5, 6. You should have 6 of them by the time you're done. And we know that these are going to keep repeating as this extends out, but get those 6. Back to the camera. Okay, since I can't write on my computer screen, I have a copy of the graph you're looking at just on a piece of paper here. So we found these intersection points. I know that this intersection point right here was at 60. And I knew this one was at 300. Okay, pi over 3, 5 pi over 3. I wrote those in. Sorry, that's kind of hard to read. I'll write a little darker. We're working in degree mode for now just because it's so much easier to see. Okay? So for this one, this intersection point was at, I'd have you be telling me the answers, but I cannot hear you. 420. This one over here is, let's see, I write these down because I can't hear you. This one is 660 degrees. This one right here was negative 60, and this one right here was negative 300. So the first thing we're going to do is let's just look at this one. Notice that this is on the downhill part of my cosine curve. So I want to compare that one to all of them in the same spot. So notice these are all hooked together. These are all on the downhill side of that cosine curve. If I go from here to here, that is a difference of 360 degrees. Same thing if I go from here to here, it's 360 degrees. So just guessing, what do you think this next one's going to be? How would I find it? I'm just going to add 360 degrees. So 420 degrees plus 360 degrees, this should happen at 780 degrees. Okay, so they keep changing by 360. So what I find is that all of my solutions are 60 degrees, plus I just need to keep on adding multiples of 360. So I have 60 plus 360. Now how am I supposed to show that I want all of the multiples of 360? What I do is I use the letter n. I think some books use the letter k for constant. I usually use n for number, I guess. And n has to be an element of the integers. So it can be -1, 0, +1, 2, 3, not fractions though. We're looking for whole number multiples. Okay, so if I multiplied it by 10 and added it to 60, it's going to be another solution. It's just going to give me an infinite number of them. Now when I look at this one, the 300, if I add 360, I get 660. If I go backwards, I get -60. Now if I go backwards again from here, what would the next one over here be? So if I take -60 and subtract off 360, I get -420. It's just those whole number multiples of 360 keep getting added on. So that one though started at 300 degrees plus the integer multiples of 360. I don't know if this is notation you've seen, but that Z stands for integers. So n is an element of the integers. Okay, now, they didn't want us to give our answer in degrees, so we're going to need to change all this into radians, which is easy enough to do. So 60, I'm going to put it as pi over 3. And instead of 360, I'm just going to put 2 pi n. N is an element of the integers. So that's one set, and then I'm going to say 5 pi over 3 plus the integer multiples of 2 pi to get the rest of them. Okay, so those are all of the solutions for this problem. So if I have cosine of x equals 1/2 and I want all the solutions, x equals that. Okay, they're all solutions, and it's a lot of them. Okay, so let's do some other ones. So the first one is the sine of x is equal to negative radical 2 over 2. I want to find all solutions. Now notice this one is not telling me whether they want it in degree mode or radian mode, which means you have your choice unless your teacher tells you otherwise. So on this one, I tend to think in terms of the unit circle. The sine ratio is negative. So the first thing I need to think about is in which quadrants is the sine value negative? Well, it's negative down here in quadrants number 3 and quadrants number 4. So I'm talking about angles down here. So I just draw my little reference triangle. This should look familiar to you. You should know which angle has a sine ratio of radical 2 over 2. It's 45 degrees. Since it's negative, it's going to be negative 45 degrees. Okay. This one over here would be 180 plus 45 degrees, which is, do I know what that is? 225 degrees. Okay. So when I write these, I'm going to say that x can equal negative 45 degrees plus 360 n, where n is an element of the integers. I have to say this every time, every new problem. I have to keep redefining it. And then I have that x is equal to 225 degrees plus 360 n, where n is an element of the integers. Now, I said negative 45. Could this also be 315? It could, because it's a coterminal angle. So I could have written this exact thing, and it would be exactly the same thing if I said x equals 315 plus 360n, where n is an element of the integers. They're both equivalent. Some people prefer to have both of them be positive. Some of them prefer to have the two that are closest to 0. It kind of depends on what your teacher prefers or the book you're using prefers. Okay, so tangent of x is equal to radical 3. So on this one, I'm working with tangent and it's positive. So I know that tangent is positive in quadrant 1 and quadrant 3. And with tangent, so 1, 2, radical 3, I know that this has to be a 60-degree angle. So I have a 60-degree angle, and then I also have the 60-degree angle down here in quadrant 3, which would be 240 degrees. 180 plus 60 makes it 240 degrees. So my solution to this one is going to be that x can equal 60 degrees plus 360 n, where n is an element of the integers, or it can be 240 degrees plus the 360. Now we've done a couple examples where we have to find all solutions. Sometimes they're going to restrain you to between 0 and 2 pi or between 0 and 360. So make sure you know if you're supposed to find all solutions or just some of the solutions. Okay, so those are the simpler ones. Then we get into problems like this. Okay, now we're going to have to employ some different methods to get answers to these. When I look at these, I need to try to find out what values of cosine make this true. And I look at this and I don't know, because it's not something simple like, you know, the sine of x is equal to radical 2 over 2. I have a whole expression on this side that I have cosine squared x plus cosine x minus 2. So when I look at this, I try to think of things I've solved that look similar. And this looks very similar to solving something like y squared plus y minus 2 equals 0, where I would just factor and then use the zero product property. Now I'm going to do the same thing with this. So I'm going to use I'm trying to factor and use the zero product property. So I'm going to factor this. So cosine squared of x, I can factor down to cosine x and cosine x. And I can multiply together to get negative 2. I have a negative 2 and a positive 1, or a positive 2 and a negative 1, and I need to choose which one is going to give me a positive cosine, so I need a plus here and a minus there. Okay. Now, since I have it in factored form, I'm going to go ahead and use the zero product property. So I have the cosine of x plus 2 equals 0, or the cosine of x minus 1 equals 0. Okay. Now when I simplify these down, I get the cosine of x equals negative 2, or the cosine of x equals 1. Now when I look at this one, can the cosine equal negative 2? Is negative 2 in the range of this function? And it's not. So this one is no solution. That doesn't help me at all. But this one, where does the cosine of x equal 1? I know that that happens at 0 degrees or 0 radians. And if I want all the solutions, I just have to look at all the whole integer multiples of those. So I have x equals 0 plus, I can either say 2 pi n, where n is an element of the integers, or if I'm working in degree mode, I would put a 360 n, where n is an element of the integers. Okay, so that one I just factored. So we're using a lot of the algebra stuff that we learned in previous courses, but now we're using it with sines and cosines and tangents. So here's another one that's very similar for you to try. So take a second and try to solve this one, and then compare answers with somebody close to you. Okay, so hopefully everybody got answers to that one. There should have been a couple. When you factored this one, it factored down to tangent x minus 2 and tangent x minus 1. Then when I do the zero product property, I have the tangent of x minus 2 equals 0, the tangent of x minus 1 equals 0, or I get that the tangent of x is 2, the tangent of x is 1. Oops, sorry, 1. Now, from here, I need to use my calculator to decide where is the tangent equal to 2. This is not one that comes from a special right triangle that I just already know. This one is, however, where is the tangent equal to 1? At 45 degrees. And I also know that it happens at 215 degrees. But we'll talk about that here in a second. Put that in parentheses. But the tangent of x equals 2. You should all know how to do this on your calculator, but we'll go over it just in case. So on your calculator, there, we just want to take the tangent inverse. Now we worked on these in a previous section. So I'm going to do the tangent inverse of 2. And I believe my calculator is in degree mode, but let's see what we get for an answer. 63.43, and that is degree mode. Okay, and I did the other one in degrees, so we'll keep this one in degrees. So 63.43 is the tangent inverse of 2. So that's going to be one of my solutions. So go back to the problem here. So I know that x can equal 63.43 degrees. So I've got a couple of solutions. Are you back on the document camera? There we go. Okay, so 63.43 degrees. Now, the tangent function, if you remember from a previous section, the period of a tangent is pi, not 2 pi. It repeats every 180 degrees, or pi radians. So on this one, to write all the solutions, I'm going to say 63.43 degrees plus 180 degrees times some number n, as long as n is an integer. And that's why I put the 215 in parentheses here, because for this solution, I'm just going to say 45 degrees plus 180n, where n is an element of the integers. Okay. Okay, this should be 225, not 215. Okay. So if I add 45 plus 180, I get 225. So I don't need to worry about listing that second solution on that one, even though it's positive in quadrant 3. So this will give me all of them. So when you're working with tangent, you need to be careful, because the period is only 180. Now I don't know if you would get marked down partial credit, or if you just missed the problem if you listed each one separately and said that they repeated by a multiple of 360. It's kind of redundant, but it's technically not the wrong answer. But I don't know that I would give you full credit for that. Okay, so here's another one. It's starting to get a little more complicated. I wrote on that paper. Okay. So on this one, we're looking for all the solutions, and again, they want exact solutions, so we're not going to be able to just use our calculator and get the answer. So I look at this one and I have a cosine squared and I have a sine. So I'm not going to be able to factor this like I want to, because it's just not, it doesn't look right. It's like having a y squared and an x. So the nice thing about trig functions is I have ways to turn a cosine squared into a sine squared, and that's that Pythagorean identity. Remember that cosine squared of x is equal to 1 minus sine squared of x. I'm going to substitute that in and distribute and clean it up and see what I've got. So I'll start by doing that. So I have 1 minus sine squared of x minus sine of x equals 1. Then after I distribute, okay, now I'm going to set this equal to 0 because I do see this descending power of sine, so I'm thinking I'm going to be able to factor this. So I'm going to subtract off the 1 and then combine like terms. So I have negative 2 sine squared of x minus sine of x. 2 minus 1 is plus 1 equals 0. Okay. Now I want to factor. harder for me to factor when I have a leading term of -2. If you want to, you could divide both sides by -1 to make this be positive. We'll go ahead and just deal with it today though. -2 sine of x, sine of x, 1, 1. These can either both be plus or both be minus. If I make them both plus, it's going to work for me. So I know that -2 sine of x plus 1 equals 0, or sine of x plus 1 equals 0. Those are my two possibilities. I'm going to subtract the 1 and divide off the -2, so I get that sine of x is equal to positive 1/2, or the sine of x is equal to -1. So I think of my unit circle and my special right triangles, and I know what angles give me a sine of 1/2, and that's 30 degrees. But remember, the sine is positive in quadrants 1 and quadrant 4. Or I'm sorry, quadrant 2. So if this is 30 degrees, this angle over here would be 150 degrees. So I have two possible solutions. And then where is the sine equal to -1? That only happens at 270 degrees. So in this one I have three places that this is going to be true. Now they want all the exact solutions, so I'm going to have to add the multiples of 360 to these. So I get x equals 30 degrees plus 360n, where n is an integer. I have 150 degrees plus 360n, where n is an integer. Or I can do the same thing with 270, so 270 degrees. N is an integer. So those are my three possible solutions, or the three solutions, sorry, for that one. Okay. Now we have one more here. Actually, I have a couple more. This one is a little bit different. They want me to find the solutions for this one. And when you look at this, there's not a substitution that we can make readily. I can't just substitute a cosine in for a sine unless I use a cofunction, which is only going to complicate things more. I don't see this looking like it's going to factor because I don't have descending powers. So you're kind of unsure what to do. So on this one, I'm going to start by squaring it. Now this is a strategy that you can use, but you have to be careful because when you square both sides of an equation, you introduce potential extraneous solutions. So it's possible that the solutions I get to this problem might not all work. So I'm going to have to make sure I go back and check all of these. So when I square this out, I'm going to go ahead and just multiply this out, and I get sine squared of t plus 2 sine t cosine t plus cosine squared t equals 1. So I multiply that out. Now when I look at this, I see sine squared of t plus cosine squared of t. And I know that these two things together are equal to 1, that Pythagorean identity. That's probably the most powerful one that we use. So I end up with 1 plus 2 sine t cosine t equals 1. And then I recognize this. Does that look familiar to you? That's one of those double angle identities. So on this one I'm going to subtract off the 1, and maybe I'll be able to use that. Maybe I won't need to. So when I look at this, I don't even need to use that. I can use the zero product property. I have 2 sine of t equals 0, or the cosine of t equals 0. And then I'm just going to decide where that happens. So where is, divide off the 2. Where is the sine value equal to 0? At x equals 0, or x equals 180 degrees. And where is the cosine equal to 0? Or I did x, I'm sorry, I should be using t. And where's the cosine value at t equals 90, or t equals 270? Now technically, this was the open interval, and I don't know if I wrote that down wrong. Usually they include one of those. I'm going to change this to include the 0. Technically I wouldn't include the 0 way that was written. Okay. Now I want to check all of these because remember it's possible that they're not all solutions. So to verify that something's a solution, I need to plug it into my original equation. So I need to look at the sine of 0 plus the cosine of 0 and see, does that equal 1? Well, I know the sine of 0 degrees is 0 and the cosine of 0 degrees is 1. So does that one work? Yes, this is a solution. Then I check the next one, the sine of 180 plus the cosine of 180, and I want to know if that equals 1. Well, the sine of 180 is 0, the cosine of 180 is -1. So this one does not work. So I have to cross that one out. Now I need to go back and I need to go through and check all of these. So the cosine of 90 plus the sine of 90, I got those backwards, equals 1. So cosine of 90 is 0, the sine of 90 is 1. This one works. I'm thinking that the 270 probably won't, but we'll check it. Cosine of 270 plus the sine of 270. Cosine of 270 is 0, the sine of 270 is -1. So this one does not work either, so I cross it out. So I have two solutions. Now this one only wanted the solutions between 0 and 360, so I don't have to do the multiples of 360. My answer is just t equals 0 or 90, 0 degrees or 90 degrees. Okay. Now this is a strategy to use, but remember, be very careful if you square both sides because you will introduce new answers into your equation that you don't necessarily want. Okay, we have a few more. This one's not difficult, but we just have to kind of go about it a different way. I see this multiple angle in here. The sine of 3x is equal to 1. And I need to find all the solutions. Now graphically this is fairly easy to do. We could just type it in our graphing calculator and find the solutions. But they're not going to be exact answers if we're working in radian mode. And a lot of times they're going to ask to see things algebraically. So when I look at this, I know that the sine of pi over 2 is equal to 1. And that's the only angle between 0 and 2 pi that is equal to 1. Okay? The only place on the unit circle that has a sine value of 1 is at 90 degrees. It's the only place. So when I'm looking at this, I want to say, well, I just want the 3x needs to equal pi over 2. Now that's going to for sure give me one solution, but remember that I might need to consider some different multiples of those. So I'm going to put that plus 2 pi n on there, okay? Because notice this is multiplying x by 3, so this is kind of changing things a little bit. So then I'm just going to solve this. I want to solve it for x. So I have that x is equal to pi over 2 plus 2 pi n, and everything gets divided by 3. So fractions and fractions, I don't like those, so I'm going to change those to x equals pi over 6 plus 2 pi n over 3. And then I just want to find some values of x that will work. Now remember, x has to be between 0 and 2 pi. So I want to find some values. So if n is 0, I get pi over 6. Okay, so if n equals 0, I have pi over 6 plus 2 pi times 0 over 3, which is just 0, and I get pi over 6. Okay, that's one possibility where that will work. And if you think about that, what's pi over 6 times 3? It gives me pi over 2, which I know has a sine value of 90. Now what happens if n is equal to 1? I have pi over 6 plus 2 pi times 1 over 3. So I have pi over 6 plus, I'm going to change this to 4 pi over 6 so I can add it up. 4 pi over 6, and I get 5 pi over 6. Okay? 5 pi over 6 is still in the same interval. if I take 5 pi over 6 and multiply it times 3x, I get 15 pi over 6, which also is a coterminal angle with pi over 2. So I'm still finding solutions, and I'm going to keep going until they're too big. So I've used 2 pi over 6 plus 2 pi times 2 over 3, and I get pi over 6 plus 4 pi over 3, and I'm going to write that as 8 pi over 6, which is 9 pi over 6, or 3 pi over 2, which is still in this interval. Okay, so far I have 3 solutions. I'm going to try one more. I think that this is going to make it too big, but we'll try it. Plus 2 pi times 3 over 3. Those cancel out. Well, I know that if I add pi over 6 to 2 pi, it's going to be outside of my interval. So my solutions to this problem are x can equal pi over 6, 5 pi over 6, or 3 pi over 2. So I end up with 3 solutions to that one. And we've solved this algebraically rather than just solving it via graphical means. Okay. 2 more examples and we'll be done. Okay, so this one, sine x cosine x equals 1. Now, things that pop into my head, if I subtract off the 1, and I could somehow factor this, I could use the zero product property. But if I subtract off the 1, I don't have any way to factor this, so I don't think that's going to work. I can't divide this stuff off. But this looks a lot like a multiple angle identity to me, and that I might be able to use that, maybe. So if I make this, if I multiply both sides by 2, let me check my I multiply both sides by 2, I see that this is a multiple angle, so this is actually equal to 2, or sorry, not 2. This is equal to sine of 2x equals 2. Now when I look at this, can the ratio of any angle ever be 2 if I'm working with the sine function? This can never happen, so this has no solutions. I don't even need to look any further at this one, because the ratio can never be 2 of any sine, of the angle of any sine value. So that one just has no solutions. Okay, and that will happen sometime. Usually if I get a no solution, I go back and double check it either graphically to make sure that that's really going to be the case, and in this case it is. And the last one that we'll look at is this one, and it's a simple one. 2 sine theta equals cosine theta. So I look at this one and I notice that there's nothing but multiplication involved in this one, so I'm just going to divide off the sine of theta from both sides, and I get 2 is equal to the cotangent of theta. Okay. Now, I'm not real comfortable with cotangent, so I tend to think of my proportion rules, and I'm going to flip this upside down and say that 1/2 is equal to the tangent of theta. Okay, that's easier for me to use. Now this is not one that we know, so I'm going to have to take the inverse of both sides. So the tangent inverse of 1/2 is going to equal theta, and you'd use your calculator. I'm just going to write down because I know that you all can do this. So theta in this case is equal to 26.57 degrees. We're still going between 0 and 360. Now remember though that the tangent, so if I have a 26 degree angle right here, 26.57, I'm going to have another one exactly 180 degrees beyond that. So I have that one, and I have 26.57 plus 180, which is equal to 206.57 degrees. So this one has 2 solutions in it. Okay, it's not repeating by 2 pi. Tangent repeats by just pi. So that's the answer to the last one. Now there's lots of different strategies for these problems, and you can't think that each problem is going to be just like the next one. So every problem you have to look and go through different possibilities and things that might work and try anything you can. And again, they get easier the more you do. Thanks.